Hello everyone, this is Randy again from Programmer Zen. I hope everybody's doing well. This is a follow-up of our data structure series where we created a stack to allow us to parse an arithmetic expression that includes priorities, so you get the correct answer and the answer matches what the Apple calculator shows, but it could be quite confusing. There's a lot involved. There's stacks and generics and priorities, and so if you're still a little bit confused, follow this video and hopefully you'll be an expert by the time it's over. So to start off with, I think what we're going to do is we're going to use a diagram and on paper show you exactly what the process is so you fully understand what we are doing, and then we're going to single step through the code once you understand what the process is, and maybe you'll better understand exactly what's going on. Arithmetic parsers use what's called a PEMDAS priority scheme. What PEMDAS does is it makes the priorities, they do parentheses first, then the exponents, then the multiply and divide, and then the add and subtract. So in the very first example, 2 times 5 plus 4, the 2 times 5 gets done first, so you'll get 2 times 5, which will be 10, and you add 4, and the final answer will be 14. In the second example, the multiplication is done first again. So you do the 4 times 5, which is 20, and then you add the 2, and the answer will become 22. And in the final example, the exponent is done first. So you do the 5 squared, which gives 25, and then you do the multiplication times 2, which gives you 50, and then you add the 3, so the final answer will be 53. So let's go through what the algorithm does on the first example. 2 times 5 plus 4. So what the algorithm does is it starts parsing character by character. So the first character it hits is a 2, and it says, okay, that's a number. And it'll start parsing until it either runs out of characters or hits a character that's no longer a number. So it'll parse until it hits the asterisk or the multiplication symbol. And then it says, okay, we now have a number 2, and we're going to push the 2 on the number stack, and then it has the operand as the multiplication. So right now we have just a 2 on the number stack and an empty operand stack. So the algorithm says, okay, the operand stack is empty, so I'm going to push the multiplication onto the stack. And then it starts parsing again. It does the 5 until it runs out of characters or hits a non-numeric number. So it parsed a 5, so it throws 5 on the number stack, and now we have an operand of a plus. And what it's going to do is it's going to look at the top of the stack, which as of right now, it's the multiplication symbol, and it's going to say, is multiplication a higher priority than addition? It is. So what it's going to do is it's going to pop off the numbers, number 1 and number 2, in reverse order. So number 2 becomes a 5, number 1 becomes a 2, and the operand is the asterisk, and all those gets popped off the stack. So as of right now, we have 2 numbers and an operand and an empty stack, both 2 empty stacks. So it's going to evaluate. So it's going to say 2 times 5 is 10, and it's going to push it back on the stack. So now we have 2 stacks. The number stack has a 10, and the operand stack is still empty. So we have a plus. But since the operand stack is empty, it just pushes the plus onto the stack. So now we have a 10 on the number stack and a plus on the operand stack, and it starts parsing again. It hits a number. It parses 4 until it runs out of characters, and it pushes 4 onto the stack. Now what we have is we have a stack with number 1 now is going to be 10. Number 2 is going to be 4. The operand is going to be plus, and it's going to go 10 plus 4 equals 14, and then it will push 14 back on the stack, and that will be the answer when the parsing is done. So now the second example is exactly like the first, except for when we do the multiplication and evaluate the priority of the plus is not greater than the multiplication, so it'll push the multiplication onto the stack, and so we'll have 2 operands on the stack. So it parses the 2, it throws it on the number stack, it parses the operand plus, throws that on the op stack, parses the 4, throws that on the number stack, so we now have a 4, a 2, and a plus, and it's going to evaluate the multiplication. The plus is not greater than the multiplication, so it throws the multiplication onto the op stack. So now we have 2 numbers on the number stack, 4 and 2, and 2 operands on the operand stack, multiply and addition, parses the 5, throws it on the stack. Now we're out of characters, so it's going to start evaluating the stack. So it gets the 5 and the 4, it multiplies it, throws the 20 on the stack, then it does the plus, so you have a 20 and a 2. So it says 2 plus 20 equals 22. It pushes that on the stack, and that will become the answer. So there's one thing you need to notice here, is that the top of the stack always has the highest priority. Because if you ever go to add something to the top of the stack, and the priority is higher, it gets evaluated. So in the next example, you're going to see when the multiplication gets added, it's the top of the stack. When you go to do the exponent, the multiplication is a lower priority, so the exponent gets added to the stack, and now there's 2 operands on the stack. And when you go to do the plus, the top of the stack is the exponent, so it gets evaluated. The number gets pushed back on the stack, and before you can add the stack, the next top of the stack is the multiplication, so it gets evaluated and put back on the stack, and then the plus gets added. So the top of the stack always has the highest priority. So in this example, you're going to parse it, you're going to get a 2, you're going to put it on the num stack, then you're going to get the multiplication, the stack is empty, so it adds it to the op stack. Then you're going to do a 5, add it to the num stack, and then the exponent, the multiplication, is a lower priority, so the exponent gets added. So at that point, you have a 2 and a 5 on the num stack, and a multiplication and then an exponent on the op stack. And then it's going to parse the 2, put it back on the num stack, and then when you go to evaluate the operand plus, the top of the stack is the exponent, so the exponent gets evaluated. So the exponent's 25, so the exponent gets removed from the op stack and 25 gets pushed onto the num stack, and then it's going to go to evaluate the plus. So the multiplication is a higher priority, so it's going to multiply the 2 by the 25 and push 50 on the num stack. Now we have 50 on the num stack and the plus on the op stack, and then we're going to add the 3. So we're going to have a 3 in the 50 and a plus, and when those two get added together, you get a 53. So it's worth noting that the top of the stack always has the highest priority. That being said, to understand this algorithm is quite simple. When you parse a number, you always push it on the num stack. When you parse an operand, you can only push it on the op stack if it's the highest priority on the stack. So if the operand on the op stack has a higher priority than what's going to get pushed, you must evaluate, and you must continue evaluating until the op stack no longer has a higher priority than what you're adding. So that's the algorithm we're going to use, and let's do an example and single step through it. All right, in order to debug this, I added 3 print statements. One where we print out each character as we are parsing it, and at the very bottom, I added a routine to dump the stacks. So I'm going to print out each character as we go, and every time we push a number or push an operand, we're going to dump the stacks. We're going to print out the num stack and the op stack. So let's see what happens. All right, so what we're going to evaluate is open paren 2 plus a negative 3 times 5 squared minus a positive 3. And let's single step it and let's go through it. All right, so we're going to print out each character as we go. And before we do that, I want to clear this. Here's the message. The message is, all right, the first character is an open paren. And let's single step through. It's not a decimal point or 0 through 9. So we're going to go through here and it's going to say if parsing number, which it's not. It's going to say if not is op, it's not, it's looking for a number, and it's going to say if it's a minus sign, no it's not. Is it an open paren? Yes it is. And so like we did in the example as we were building it, we're going to increment the number of open parameters we have, and we're going to push it onto the op stack. So we just printed out the number stack, and look what we got. Number stack. Arithmetic parser demo, it's a stack of type double. Well, that didn't really tell us a whole lot. All it really does when you do a print on a class is just describe what the class is. What you need to do is instead of using a print, they have a debug statement for classes, and it's called dump. So let's dump them now. So we're going to dump the number stack, and we're going to dump the op stack. Let's try it again. All right, let's hit parse. Let's get rid of all the startup messages. All right, we have an open paren. Is it a decimal point? No. Is it a 0 through 9? No. Are we parsing a number? No. Is op? Yes. Is op is false, and so not false is true. Is it a minus? No. Is it an open paren? Yes. Open paren plus equals 1. That's letting the software know that we have at least one open paren. When we reach a closed paren, we are going to push the op. Number stack should be empty. It is nil, and we're going to dump the op stack. And the op stack has a head pointer, and it's got one element, which is the open paren, and the next pointer is nil. Let's do one more. Now we have a plus sign. So now we have a num stack with 2, and our op stack has a open paren. So now we have one number and one open paren. Let's do one more. So our num stack now still has a 2. The op stack has a plus and an open paren. Now this is great for seeing how it's organized. For instance, if you really don't understand what this next pointer is, the next pointer is just another one of these. So next is exactly another one of these. It has an element and a next, but this is a little verbose. We're going to do a custom print instead of using this dump or a print that doesn't do anything to print out something a little more useful. All right, to make a custom print in any class, you have to define the protocol custom string convertible and then declare a variable called description and return a description string. Now, you guys don't have to type this in. You can just follow along. You can download the whole source code, but I recommend every data structure that you develop, you need to give it a custom print statement to make it tailored to your needs. So what I'm going to do here is, first thing I do is I make a variable called current. I assign it to head, so that's going to be the first element. I declare an array called result of type X, which is the generic type, and I instantiate it. So we now have an empty array, and then I'm going to go through every element in our array, and what I'm going to do is I'm going to append the element to that array. And then I'm going to go to the next node. And when we're all done traversing our list, we are going to return the array result.description. And the reason that works is because arrays implement the custom string convertible. In a sense, what we are returning is the array custom string convertible description implementations string. So what we need to do is we need to go back to our parser, and we're going to use this print statement again, but it's going to be a custom print this time, and we're not going to use this verbose dump. All right, so let's see what happens. Let's go through this. Okay, we're going to go through it again. We're going to go one character at a time, and here's the expression. It's open paren 2 plus minus 3 close paren times 5 exponent 2 minus a plus 3. So the first character is an open paren. What that's going to do is it's just going to push it on the stack. So right now we have an open paren on the op stack, nothing on the number stack yet, and our next character is a 2. So it's going to parse the 2 until it either runs out of characters or it hits a non-numeric character, which will be a plus. So as soon as it hits the plus, here's the plus. It's going to push the 2 on the stack. So now we have a 2 on the number stack, an open paren on the op stack. So we've gone through the open paren and the 2, and the character we're evaluating is the plus. And since the op stack is an open paren, it's going to push the plus on the stack. So it pushed the plus on the stack, and we now have a negative. So we took care of the parentheses, the 2, we have the plus. Now we're at a negative, and this is interesting because it's expecting a number, and it got a negative sign, which is one of the 3. It's not parsing a number. And yes, is op is false, so that becomes true. Is that a negative sign? Yes. So it's going to multiply the sign by -1. So that's going to force this 3 to become negative. That's all it did was change the sign. Now that we got a 3, it's going to say, yes, we're going to be parsing a number until it runs out of numeric numbers or runs out of the expression. So we're going to hit the close paren. And what that's going to do is it's going to push -3 on the stack, which it just did. And then what it's going to do is it's going to evaluate the parentheses. Resets everything. It's not an op. Is it a close paren? Yes. Do we have at least one open paren? Yes, we have one. So that's a balanced parentheses. We're going to decrement it. And what it's going to do is while the top of the stack is not an open paren, it's going to evaluate it. We have a plus. So what it's going to do is it's going to go -3 plus 2. It's going to pop the 3 and the 2 and the plus and push a -1 on the stack. And all we're going to have is a open paren. We're going to evaluate it while peak. And now what we're going to do is we got to get rid of that open paren because it's already been evaluated. So now what we did is we evaluated the open paren 2 plus a -3 close paren. And we're going to have -1 on the stack. And what it did is, since this op stack was empty and the character was a char, a multiply, it pushed it on the stack. So now what we have is we have the parentheses evaluated with the multiplication symbol on the stack, We have a character 5. So it's going to do the character 5 until it hits a non-numeric character, which will be the exponent symbol. So now we have a 5, we have an exponent symbol. So now the 5 has been parsed. It's going to push a 5 on the stack, and then it's going to evaluate. Is the top of the stack greater than this? It's not, so it's going to push this on the stack. It's going to push the exponent on the stack. So we got the 5 on the stack, and now we have the exponent on the stack. Now we're going to hit the minus. And what that's going to do is it's going to say, is the top of the stack greater than the negative sign? Yes. It's going to evaluate to 5 squared. It's going to put 5 squared and put 25 on the stack. And then it's going to say, is the minus sign priority greater than the times? No. So it's going to do it again. So we're going to get 2 evaluations here. So we got 2. We got the minus sign. We got 2 on the stack. And we're evaluating the negative. So it's going to say, is a minus sign a higher priority than the exponent? No, it's not. So what it did is number 1 was 5, number 2 was 2, the op was an exponent. It did the evaluation, pushed the 25 onto the stack, and removed the exponent symbol. So it's now going to evaluate the minus sign, and it's going to say, is the multiplication a higher priority than the minus sign? Yes. So what it's going to do is it's going to do this multiplication, and it's going to remove these 2 and do the multiplication and put a minus 25 on the stack, and it's going to remove the multiplication symbol, and then it's going to push the minus sign onto the stack. And now we have a plus, which is going to be, this is a special one. It's expecting a number, but it gets a plus, and it's not going to do anything because it wasn't a minus sign. It's not a parentheses. And if it wasn't a plus, it would return a result. But since it is a plus, it's just going to go right around this and continue to the next character. Okay, so now we have negative 25 that evaluated all the way up to here. And we have a minus on the stack. We just evaluated the plus, and it didn't do anything. We have a 3 now. That's going to end. And we're going to fall through to where we've exhausted the entire expression. And the first thing it's going to say, are we parsing a number? Yes, we are. We are parsing a 3. We're going to push a 3 onto the stack. And then, while the stack's not empty, and it's not, we have a 3, a negative 25, and a minus. It's going to evaluate the stack. So it evaluated a negative 25, a 3, and a minus, which became minus 28. The 3, the 25, and the negative got popped off the stack. So our stack was now empty, but once it evaluated it, it put 28 on the stack, which is now the answer. Let's pop that off the stack, and parse number now equals negative 28. That's the answer. And here we're going to round it. This was explained in the original video. What we're going to do is we're going to multiply it by 1 with 8 zeros, and then we're going to round that to the nearest integer, and then we're going to divide it back by 1 with 8 zeros. And what that's going to do is it's going to round it to 8 digits, and that's what the iOS calculator does. So I'm just mimicking that. Now it's going to check to make sure that both stacks are empty, because once we pop the 28, both of them should be empty. If not, there's an error. Result will have an invalid expression. So if result is blank, there was no errors. And what we're going to do is we're going to say, this is where we're going to see whether it's an integer or not. So I explained this in the original tutorial, but I'm going to do it anyway. You take any number and divide it by 1. If there isn't a remainder, it's a whole number. For instance, 7 divided by 1, the remainder will be 0. 7.1 divided by 1, the remainder will be 0.1. We're going to put parse number into the result, and now result equals negative 28.0. So if remainder is 0, we want to convert this to an integer, because we don't want 28.0, we just want 28. So result is now going to be a string, and it's going to be just negative 28. We're going to return a result, and that's going to be the answer. So we now have a fully functional parser that you can use in your apps. And in our next video, what we're going to do is going to be an easy one. We're going to just change the content view to, instead of using the keyboard to type in the expression, we're going to make a front end for a calculator, and you will have a fully functional calculator, very similar to what the iOS has. So I'll see you in the next video, but till then, happy computing.